1, 2, yep, there we are. 1, 2, 1, 2, yep. I've got YouTube running now. 1, 2, 3, just making sure the levels are good. All the initial startups, hassles. Good evening, everyone. And just getting that level right again. 1, 2, 3, 1, 2, 3. I can very easily put too much level into YouTube, so I think we've got it right. Good evening, everyone. This is VK3EKH, the official station of the Astronomical Society Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South, as I'm pressing buttons here to make sure things are working. Okay, we're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and simulcasting on 160 meters AM, 1865 kilohertz, around about 100 watts on 160. And I am streaming YouTube, so if anybody wants to see the variety of pictures that I'll run tonight, by all means, please go to my YouTube channel, VK3CSJ, in the Google search engine, and look for the live symbol. Once you type in VK3CSJ, you'll very quickly see the little live symbol, which is this broadcast. So that's about all we're doing tonight. We'll see you next week. We also have an email address, so if anybody wishes to send signal reports, vk3ekh@gmail.com, vk3ekh@gmail.com, and I'm looking at the inbox as we speak. There's also a chat window, a Discord chat window, which is available via the ASV website at www.asv.org.au under the Radio Astronomy tab. And g'day to Richard, VK3VRS, who's already up there on Discord. Once again, you can find the link to the Discord set up via the ASV website at www.asv.org.au under the Radio Astronomy tab from the homepage. Okay, with a few articles tonight, and that I didn't get to bed till about 5 o'clock this morning, so if I fall asleep halfway through a reading, you'll know why. We had lots of rain here yesterday, as most of Victoria did. We had about 65 millimetres fall yesterday, and a part of that rainfall came into our barn at the back of the place. We often get flooded if there's too much rain, and the back of the barn by about 10 o'clock, we don't have very good drainage, and the water did seep in underneath the wall, between the slab and the wall, and sure enough, we got lots of water. So by 3 o'clock in the morning, we had managed to mop up most of the water, but the damage was done. So at the moment, it's fortunately dry, but the floating floorboards are a little bit worse for wear. It's not the first time. Anyway, that's another story. All right, just allowing time for folks to come in on the broadcast tonight. G'day, Don. Don's VK3HDX has joined, and hope the signal on 160 AM is good. All right, today's the 14th of October, which means for me it would be Mum's 96th birthday. So if Mum was still with us, she would have been celebrating her 96th birthday today. So happy birthday, Mum, no matter where you are. And actually, I've got a picture there. I was going to bring up a little pic. So it's not a very good high-res image. I was hoping to get the picture that I got that from was a bit better quality, but I apologise on the low res. It's actually quite a high res picture, so I actually pulled that quickly off Facebook. So, but there's my mum holding our little Jessica cat, who also passed away about 12 months ago. Little Jess. So that's me mum, taken about, well, it'd have to be over a year ago. But happy birthday, Mum. So there it is. All right. The Astronomical Society, in fact, I'll dedicate the broadcast to Mum tonight. The Astronomical Society of Victoria was founded in 1922, comprises well over 1,600 members scattered about the state and the country. Membership of the Society is open to all persons with an interest in astronomy, and the Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, which was last week. Meetings start at 8 p.m. at the Mullier Hall, National Herbarium in Burwood Avenue, Melbourne, which it did, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. Meetings usually kick off at 8 o'clock on the noggin and aim to finish by 10 o'clock. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor which is managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible to members too. The Society also has a number of 200mm reflectors which are available for a short period loan, part of the ASV's loan scheme. So if you wish to explore the use of a telescope, you can. Members are also encouraged to make use of the Society's country property located near Heathcote, roughly 90 minutes north of Melbourne. There are a range of instruments available for members to use, the larger two requiring appropriate training, which range from 300mm to 1000mm in diameter. Also located on the site is the 8.5 fully steerable radio telescope, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. There's about 20 sections that make up the various activity groups. In a nutshell, you've got deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics. Historical studies and research in astronomy in general. That's just a nutshell. Contact details for various section directors can be found via the ASV website at www.asv.org.au or within the yearbook if you happen to be already a member. But membership of the Society can be gained through the homepage of the ASV website, again at www.asv.org.au. And apart from the magazine that Crux gets published, there's also what's referred to as a Crux Extra, which is every other week it gets released, giving members a constant reminder of events that are coming up. Okay. Any other further information from or to do with the ASV, you can write a letter to the ASV, to the Secretary, the Astronomical Society of Victoria at GPO Box 1059, Melbourne, Victoria 3001. But like I say, the ASV website is perfectly a good place to go to for further information about the Society, www.asv.org.au. Last Wednesday was our monthly meeting, and we had a very interesting presentation by Kate Ross. Kate Ross is a postdoctoral researcher. In fact, I've got a picture here I've taken off the video that was done. This is Kate Ross for those watching the YouTube stream. So like I say, Kate, or Kat, K-A-T, I think it must be Kat. Kat Ross is a postdoctoral researcher at the International Centre for Radio Astronomy Research, or ICAR, I-C-R-A-R, at Curtin University, which is in Western Australia. She is also an activist and a science communicator, and in 2017 founded her movement to increase the diversity of scientists mentioned in high school courses. In this presentation, Kat will discuss how she studies the universe in radio color, characteristics, the odd behaviors of baby black holes in distant galaxies, and so yes, that was last Wednesday. Again, she's a postdoctoral researcher at the International Centre of Radio Astronomy, Curtin University, and apparently very interested in, or founded a group of some sort, which was called her movement to increase the diversity of scientists mentioned in high school courses. I guess that's got something to do with STEM. But anyway, you can see she's on TV just now on the YouTube stream. That's Kat Ross, and she's a very colourful lass, absolutely full of enthusiasm on the subject at hand, and you can see her. The session was recorded last Wednesday on YouTube. So if you type in the Astronomical Society of Victoria on YouTube, you'll find this link, or you'll see the picture straight away of Kat Ross, doing her presentation. So there it is, good old Kat. Okay, all right. Let's get a jig along. NASA. All right. Now I'm just going to get up for a second and turn something down before it annoys the hell out of me. All right. We're on 23. Now, in talking about that, there's no ATV repeater tonight either. The RTV repeater is still in maintenance mode. All right, Cassiopeia Nebs has joined us on chat. G'day, Nebs. And we also have nobody else there, so apart from Richard. So anybody wishing to send emails, vk3ekh@gmail.com. There's only one email at this stage. 10:15, there should be a 10 at least. Well, close to it. All right, what we're going to talk about now is NASA's Juno mission reveals a bizarre details of Europa's surface. And we've got a juicy image of Europa's surface here. Okay, there she blows. High-resolution ice paths and glassy fields make up this shot of one of Jupiter's moons. JunoCam captured this image of Jupiter's moon Europa during its flyby on September 29. Juno captured the dark side of Jupiter's moon during a flyby on the 29th. The craft came within 352 kilometres of Europa's surface, obtaining the highest resolution view of this ocean world, and I've got that picture too, which is really quite stunning. So there it is there for those watching YouTube channel. At first glance, you might think you're looking at a slide under a microscope rather than an image of an ice-coated world. In reality, however, this view covers 150 kilometres by 200 kilometres of Europa's frozen landscape, including long hilly tracks jutting out from the surface and a comma-shaped water ice blob towards the southeast, spanning some 67 kilometres by 37 kilometres. The white speckles, reminiscent of snowflakes, are signatures from high-energy particles resulting from extreme radiation surrounding the moon. And the dark areas at the upper right, centre right and lower left of the image could be an indication of activity below the crust erupting onto the surface. Europa is one of the worlds in our solar system that scientists believe is harbouring a salty ocean miles below its icy shell. This image is unlocking an incredible level of detail in a region not previously imaged at such resolution and under such revealing illumination conditions, said Heidi Becker, the lead co-investigator for the SRU, in a press release. These features are so intriguing, she reckons. Understanding how they formed and how they connected to Europa's history informs us about internal and external processes shaping the icy crust. The photo was taken during during Juno's Stellar Reference Unit (SRU) camera used to orient the spacecraft. SRU works well with low light conditions, capturing the details of the surface in greater detail. JunoCam, the spacecraft's public engagement camera, also caught 4 images of Europa during the flyby. These are being processed by citizen scientists. The Juno mission primarily studies Jupiter, but during its 45 trips around the planet since 2011, it has also snapped pictures of Jupiter's rings and Ganymede, the solar system's largest moon. Juno plans to make its debut at Io, the solar system's most volcanic body, in 2023. All very exciting. Look forward to that happening. Yep, where's my picture? There it is. Okay. You're tuned to ASV Radio, VK3EKH. All right, next article is, okay, this is, we're just going to cover a little bit of history here. Not very long, but it's an interesting little article to read out. I've been holding on this one for a little while. Okay, I've got a picture here. Okay. Meet Henrietta Leavitt, the woman who gave us a universal ruler. Cepheid variables, CEPHEID, Cepheid variable stars, act as signposts to help astronomers build a 3D picture of the sky. Here's the story of the woman who unlocked these stars' secrets. Gazing up at the sky, it's hard not to imagine the sun, moon, stars and planets as part of an inverted bowl over our heads, even if we know that that's an antiquated way of viewing the heavens. But these days we understand it's Earth, and it's Earth that's spinning daily like a ballerina while also circling the sun on its yearly journey. But the bowl imagery was and remains a reasonable way of envisaging how the skies appear to revolve around us, and why certain stars appear or disappear with the changing hour or season. But to understand the universe as it really is, we need a 3-dimensional picture of the skies. The Copernican revolution started this change in perspective, but it took until the 20th century for a true understanding of the universe's scale and layout to evolve. The researcher who provided one of the biggest keys was a deaf woman who earned 30 cents an hour. Henrietta Swan Leavitt was one of many women computers who worked at Harvard University, cataloguing stars around the turn of the last century. Women could be paid less than men, still are, and were generally seen as detailed-orientated and suited for often boring and rote work of data and analysis. Rote, R-O-T-E, it's got there. They were also barred from operating Harvard's telescopes, limiting their other astronomical options. Leavitt's particular assignment was Cepheid variable stars. These stars change how bright they are from day to day or week to week, and she noticed that in general the brighter stars had longer periods. The brighter the star, the longer it took to cycle through its variability. At first, this was nothing more than a curiosity. It didn't mean anything to anyone, but Leavitt made it very meaningful with her follow-up work. She looked at a sample of variable stars that were all near the same location in the small Magellanic Cloud. This is a tiny dwarf galaxy very near to our own Milky Way. Here, with a simple sample, her trend was even clearer. Brighter stars had longer periods. It's worth an aside here to remind readers of something you've certainly experienced in real life. If you shine a torch in a friend's face from a foot away, they will likely ask what you're thinking. What are you thinking? Because that flashlight is very bright. If you shine the same flashlight at their face from across a football field, they'll be less cranky, because the flashlight will appear much less bright to them, of course. The flashlight itself has not changed brightness, but distance has made it apparent brightness much less. So let's go back to the story. Leavitt realized something very important here. Though it's not clear, many others did at the time, because the stars in her second study were all the same place. They were all essentially the same distance from Earth. So her discovery was telling her something intrinsic to the stars themselves. The longer a star took to change brightness, the brighter it actually was. So if another star took a long time to change brightness but didn't appear brighter, then she concluded it might be farther away, thus dimming its true brightness. With this simple relationship, Leavitt turned a two-dimensional picture of the sky into a 3D one. Leavitt herself pointed out that someone merely needed to work out the parallax, a way of calculating distance that works only on very nearby stars, of a tiny handful of variable stars to calibrate the system, and turn her rough picture of near or far into an accurate map, complete with marked distances. Within a year, another astronomer named Edna Hertzsprung had done so. Perhaps Leavitt was a few years too early for her brilliant observation. Perhaps it was overlooked because she was a woman and not allowed the status of her full research, though her name is on her own published work. However, or whatever the cause, this observation sat quietly for over a decade, until after Leavitt had suffered an early death due to cancer. It was only then that Edward Hubble used her work to show how large the universe was, and that many of the fuzzy nebulae astronomers had observed for so long were actually far more distant than the stars in the Milky Way, and were in fact entire galaxies themselves. Leavitt never earned fame in her own lifetime, nor a fancy telescope namesake afterward. But when looking up at night skies, it's worth remembering that she is part of the reason we have a three-dimensional map of the skies, instead of that flat picture that sustained humans for so much of our history. There she is working in that black and white picture there. Clever, very clever. There's a lot of amazing people in this world, really. You're listening to VK3 EKH, ASV Radio. G'day John, VK3BLX has joined the chat room. Alright, next on the subject, we have, yes, now this is a little bit on the sad side. It's a radio astronomy thing, and this has always upset me, this thing about Arecibo. Fallen Arecibo Observatory Telescope won't be rebuilt despite scientists' hopes. And I got a little picture here of Arecibo before it collapsed, just for the sake of it. Okay. Puerto Rico's iconic radio telescope, which collapsed in 2020, won't be rebuilt, although the site will see a new education centre open next year. The Arecibo Observatory's massive radio dish was an unusual facility because it was a key player in 3 different fields of science: atmospheric studies, radio astronomy, and planetary radar. Opened in 1963, the telescope's observing equipment hung from a web-like platform strung over a massive dish 1,000 feet, 305 metres wide. But in December 2020, the cable supporting the platform gave out, and the equipment crashed down through the delicate dish, destroying the telescope. Now, the National Science Foundation, NSF, which owns the site, has determined that despite scientists' pleas, Arecibo Observatory won't be getting any new telescope to replace the loss. The new education project also doesn't include any long-term funding for the instruments that remain operational, which is a 12 meter radio dish and the LiDAR system. We were worried that it could be even worse than this, they might say, but okay, just close down everything. But Abel Mendez, an astronomer at the University of Puerto Rico at Arecibo who used the telescope in his research and teaching, told Space.com, but my particular hopes were higher. Instead, the NSF intends to build an observatory's legacy as a key educational institution in Puerto Rico by transforming the site into a hub for science, technology, engineering and math (STEM) education, due to open in 2023, according to the statement. The observatory is also home to Angel Ramos Foundation Science and Visitor Center, which opened in 1997. The US National Science Foundation issued a solicitation October 13 for a new multidisciplinary world-class educational center at the Arecibo Observatory in Puerto Rico that aims to serve as a hub for STEM education and outreach, officials wrote in the statement. The centre would expand upon existing education and outreach opportunities currently in place at the Arecibo Observatory site, while also implementing new STEM programs and initiatives. The statement discussion of the science facilities at Arecibo is minimal, although it does note that teams who want funding to use the existing instruments or build new ones can submit proposals that are complementary to the scope of the new centre. NSF program solicitation for the new science centre notes that the agency expects to provide $5 million over a 5-year period, according to the Associated Press. The NSF also intends to provide the observatory with a 5-year maintenance contract worth at least $1 million each year. Mendes called that enough to keep the lights on, but not a budget to support research. The telescope's troubles began in 2017 when Hurricane Maria battered Puerto Rico through the observatory, although the observatory suffered a little damage. In early 2020, a spat of earthquakes rocked the island, temporarily closing the observatory. but for a while the facility still seemed like it would be fine. In August that changed as one of the thick cables supporting the 900-ton platform slipped out of its socket and fell through the dish, leaving a gash in the delicate panels. Still, engineers developed a repair plan and said that the situation was under control. But in November, just before those repairs were due to begin, a second cable failed. As they analysed the situation, engineers determined that the telescope was too unstable to repair safely. NSF decided to decommission the instrument, but gravity won the day, with the telescope collapsing early in morning of December 1, 2020. Since then, scientists have called for the telescope to be rebuilt, or for an even more capable instrument to be built at the site to replace it. Instead, the Arecibo telescope's legacy will live on, most notably in the form of its decades of archived data. For decades, you probably will be hearing a paper from Arecibo, Mendez said. So, there it is. That's the latest on our little telescope. It will not be rebuilt. But at least the site, with its history of radio astronomy, will continue on in the form of outreach and education for the young of mind who are keen on such science, and we can only hope that that's successful. But I gather that because of the economical strife that the United States is going through, which is unbelievable when you understand what's going on over there. It's going to affect the whole world sooner or later. They obviously don't have enough money to think about building a new telescope. I suppose it's fair enough. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in good old Narrewarren South. Not many people sending emails. We've only had one email from Don, VK3EKH@gmail.com. All right. Next, mysterious dust ring around Uranus spotted in Rediscover Voyager 2 data. We didn't know this. Uranus sports a faint ring system, and this is what it looks like. Scientists have uncovered a new mystery about Uranus rings buried deep in data from NASA's iconic Voyager 2 mission. Voyager 2 flew past Uranus in January 1986, discovering 10 moons and 2 rings, while becoming the first and so far only spacecraft to visit the ice giant. One of those rings, which scientists call the Zeta ring, has frustrated astronomers ever since. They weren't even able to spot it again for nearly 2 decades. But last year, researchers got an unexpected gift: a new image of Uranus's ring system, including the elusive Zeta ring, courtesy of amateur imaging processor Ian Regan. For a long time, we thought we only had 2 images of this ring from Voyager 2, Matthew Hedman, a planetary scientist at the University of Idaho, said during a presentation at the annual meeting of American Astronomical Society's Division of Planetary Sciences on October 5. He says this shows there's a lot of information still encoded on or in the Voyager data that deserves a second look. Scientists originally missed the find because the reddish dusty ring closest to Uranus wasn't visible in any individual image. Regan, R-E-G-A-N, had to combine a host of images together for the feature to appear. He took hundreds of images, stacked them together to produce the image of the Uranian system. Hedman said This is the most comprehensive view of the Zeta ring that exists, and we didn't know it was in the Voyager data for decades. The new image, combined with previous 2 Voyager photographs, offered Hedman and his colleagues enough information to calculate the ring's distance from Uranus at about 37,000 kilometers above the planet, and to estimate its brightness. But both of these values are puzzling. The Keck Observatory in Hawaii had gathered the first observations of the Zeta ring since Voyager 2 in 2007. These observations showed the ring at 40,000 kilometers above the planet, a bit farther from Uranus than Voyager 2 observation showed. The trick is that the location of this ring didn't match the Voyager's images, Hedman said of Keck observations. Something had changed about the ring over the course of 20 years. We're still not entirely sure what that was, though, he says. And the Zeta ring didn't just inch away from the planet during those 2 decades. It went unmonitored. It also registered a stronger signal in the Keck's observations than it had in Voyager 2's view. It got significantly brighter, which means that dust got introduced into the system sometime in those 20 years. Now, what did that? Hedman says. We have no idea. Hedman suggested that Uranus could have been hit by a space rock that fragmented into debris and settled in the Zeta ring, or that perhaps the changing seasons could be responsible. But both are merely ideas. Whatever happened must have been dramatic enough to affect the rings, but also slipped under scientists' radar. NASA will begin planning a major mission to explore the Uranus system in the coming years, but scientists won't have data from that mission for a couple of decades. However, Hedman noted that the James Webb Space Telescope had captured a dazzling image of similar rings around Neptune released in September. Fortunately, there is a telescope that seems to be very good at looking at dusty rings around planets, he said, so that might be nice, he reckons. It's a good picture though, isn't it? You're tuned to ASV Radio, VK3 Echo Kilo Hotel, with the regular Friday night cast. Alright, what makes gamma ray bursts blink off and on, you might ask yourselves. In this image, which we have here, the most energetic events in the universe have a strange habit of going silent mid-blast, stumping astrophysicists. But new simulations suggest a surprising answer. With this image here, when a massive star collapses into a black hole, jets generated by the black hole during collapse can power a gamma ray burst, which is an actual image you're seeing there. That's not an artist's impression. The birth The birth of a gamma ray burst, GRB, is a stellar event. These incredible violent blasts are the most energetic explosions in the universe. In just 1 second, a GRB can release more energy than our sun has emitted over the course of its entire lifetime to date. GRBs also have a deadly reputation. They may have even played a role in one of Earth's largest mass extinctions. But for events so intense, they can be seen across the universe. GRBs are difficult to study. This difficulty is further compounded by the environments in which researchers think they are born, which typically contain dense star-forming regions nearby. But new research published on June 29 in the Astrophysical Journal Letters produces the highest resolution 3D GRB simulations to date, and is a major step forward in understanding these mysterious blasts and why they act the way they do. How to make a gamma ray burst. GRBs come in 2 flavors, long and short. Long GRBs, those lasting anywhere from a second to several minutes, are released from so-called collapse stars. When a quickly rotating massive star goes supernova and collapses into a black hole, ejecting jets of material along the way. These jets are what power the GRB. Or Gottlieb, a Sierra Fellow at the Northwestern University of Evanston in Illinois, has made a career out of studying these high-energy astrophysical phenomena. I've always been curious about stellar explosions, he tells Astronomy. But beyond the explosions, Gottlieb hopes to learn I think that's how you pronounce his name. Gottlieb. Gottlieb. What is it? Gottlieb. I don't know. Gottlieb hopes to learn more about the stars themselves. In particular, he wants to understand how and why different stars explode in different ways. He had previously studied the jets emitted by collapsars, and that's the correct word here, collapsars. Collapse, as in collapsed, but it ends with S-A-R-S. Collapse stars. It's not stars, there's no T in it, it's just collapsars. By looking at the interactions between GRB jets and the surrounding stellar material as the star is in the process of collapsing. His work used hydrodynamic simulations to model the interactions between the two. But one thing that was always missing is, how do you start or launch the jet in the first place, he reckons, or says. Probing the heart of a star itself required integrating relativistic physics into our already complex simulations. It was a daunting prospect, he reckons. Gottlieb says one of the biggest challenges they faced was sheer differences in the scale involved in tracking a jet from inside a collapsar through outer space. The black hole is 1 million times smaller than the area where the GRB is emitted, Gottlieb says. But by creating a model that could accurately resolve the jet across the vast space, researchers were able to track its evolution from birth through emission. Their approach was deceptively simple. We took a star, put a black hole in the middle, assuming that the star core has collapsed into a black hole already, and let the simulation run, he says. While it sounds simple on paper, the simulations required were more intense. But the results were worth it, the effort according to Gottlieb, as the team came away with 3 key findings. Oh, there's another image here I can put up. Okay, there we go. Wobbles and other weirdness. Long GRBs can last anywhere from 1 to hundreds of seconds. During that time, the intensity of the signal can be extremely variable. It jumps rapidly on timescales of maybe 10 milliseconds, says Gottlieb. But GRBs also have strange periods of quiescence that, before now, lacked an explanation. For anywhere from 1 to 10 seconds, the signal can blink off, dropping to 0, and staying there before resuming its extremely rapid variability, and then eventually petering out more slowly. The new models provide a simple but surprising, according to Gottlieb, explanation for these quiescent periods. The jet isn't gone, it's simply just not pointed in our direction. As gas from the collapsing star falls into the black hole, it lands on a swirling accretion disk of material around it. But the intense turmoil during the collapse causes the accretion disk to tilt, its angle relative to the black hole oscillating back and forth. Gottlieb says that since the jet emitted by the black hole and causing the GRB is always perpendicular to the disk, the unsteady disk causes the jet itself to wobble in turn. So for a given observer, what he would see is that sometimes the emission is pointing towards the observer and sometimes away because of the wobble motion of the jet. Makes sense to me. The picture you're seeing on YouTube screen right now If the accretion disk around a black hole begins to tilt and wobble, it can cause the jet it generates to also wobble, moving across the sky, which is kind of depicted in this artist's impression, I have to add. The tilting of the jet, Gottlieb says, has another interesting implication. Astronomers estimate how many long GRBs occur throughout the universe by calculating how many they see in a given area of the sky and extrapolating to areas they aren't currently observing. If we see 1 GRB per gigaparsec per year, Gottlieb explains, where 1 gigaparsec is equal to about 3.3 billion light years, then overall there are about 100 GRBs occurring because we missed 99 of them. But previous estimates assume that GRBs jet propagate along only one axis, and that is, they are pointing in only one direction of the sky and stay pointed that way. However, a wobbling jet covers about 10 times much area, so instead of assuming that there are 100 long GRBs out there for every one astronomers observe, the estimate shrinks to around 10. And that means these events are much rarer than we previously thought, Gottlieb reckons. Finally, the researchers also discovered details about another poorly understood aspect of long GRBs, their emission system. The two current prevailing theories are that GRB emissions is the result of either magnetic or non-magnetic processes inside the jet. What we found is that the GRB jet is neither magnetized nor unmagnetized, Gottlieb says. So it means all physical processes, both magnetic and non-magnetic, should be considered. More to ponder. As always, there are caveats to the results. One of the major ones, Gottlieb says, is that their work couldn't consider neutrinos, which carry huge amounts of energy out of supernovae. Including them would have required adding yet another layer of physics to their already highly complex simulations. Another important caveat is that the team's simulations began once the black hole has already formed, but its birth could also affect the jets it produces. The team hopes to investigate these added complications with future work. Though more work can always be done, the team has opened some new and exciting avenues into the long GRBs. According to Gottlieb, it's already providing useful in studies of other stellar phenomena. And one of the most exciting is in investigating gravitational waves created from the formation of stellar jets. Analytic models of GRB jets suggest that if they produce gravitational waves, the waves are at frequencies too low for most current gravitational wave detectors to pick up. But Gottlieb says the material inside the star that agitate by the jet might generate detectable gravitational waves. And finally, ultimately, however, the team is proud of the novel work they have done in producing what is, to the best of their knowledge, a first-of-its-kind simulation of long GRBs. And by learning more about the jets that produce GRBs, scientists can effectively see what is happening deep and within the stars as they collapse, appearing into a place otherwise completely invisible and unknown. Right. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. Oh, g'day Ian. Ian's our second emailer. He's sent an email. Thank you, Ian. And Joe, VK3BKI, has come up on the chat window too. Okay, we have about 10 minutes, plus or minus. What else have I got here? Yeah, okay. I think I can manage this. Yep. All right. This was published 1 day ago. The sun crackles in new images from spacecraft preparing for a close flyby. And we've got a picture of this too. It's a little GIF image that's running here. Bring that up and run that. All right. This is a short article. Okay. The sequence you're seeing below, actually, the sequence that you're seeing on YouTube, if you're watching YouTube, the sequence shows the sun in high res over a 20-day period. The sequence captures the sun over a 20-day period ahead of solar orbiter's close approach. The Europe-led solar orbiter mission has captured a stunning sequence of the lively star at the center of our solar system as it made its closest approach amid intensifying solar activity. The European Space Agency, ESA, which operates the spacecraft, released the sequence on the day the spacecraft's closest approach, on Wednesday, October 12th. The images show 20 days of the solar orbiter's observations of the star taken between September 20 and Monday, October 10. The images were taken with the spacecraft's high-resolution extreme ultraviolet imager, EUI, operating in the full sun mode that enables scientists to view the entire star. The video reveals the rotating star sparking with activity in its gaseous atmosphere, the corona, which reaches at temperatures of up to 1.8 million degrees Fahrenheit or 1 million degrees Celsius. Scientists enhanced the colours in the sequence because human eyes cannot see the ultraviolet wavelengths detected by the instruments. The solar orbiter makes regular close passes of the sun at about 1/3 of the Sun-Earth distance within the orbit of the planet Mercury. On this flyby, the spacecraft's fifth, it reached the closest point to the sun today at 3:12 p.m. EDT on a day ago. Why did I do that? Now I've missed my spot. The solar orbiter launched in 2020 doesn't make close dives towards the star as NASA's Parker solar probe, but unlike Parker, carries high-resolution cameras that wouldn't survive in extremely hot environments that Parker visits. Together with two probes, are enabling giant leaps in our understanding of the star at the center of our solar system. Solar Orbiter also marks regular flybys at the planet Venus, using its gravity to gradually tilt its orbit out of the elliptic plane in which planets orbit. These maneuvers will eventually slow the solar orbiter to view the sun's poles in detail, which no spacecraft has done before. Scientists believe that the polar regions harbour clues about how the star generates its magnetic field, which in turn drives its 11-year cycle of activity, the ebb and flow in the production of sunspots, solar flares, and eruptions. Solar activity has been picking up over the past year, causing all sorts of problems in near-Earth environment. Satellite operators have reported struggles with maintaining spacecraft orbits near the planet because of the interaction of the solar wind, the stream of charged particles emanating from the sun, with Earth's atmosphere increased the drag experienced by the satellites. In February, SpaceX lost an entire batch of its Starlink internet satellites after launching into a mid-geomagnetic storm causing a solar eruption. Caused by a solar eruption. A major solar flare disrupted radio communications in North America just as the US was recovering from the rampage of Hurricane Ian. So, I thought that was an interesting one. Nice imagery though, isn't it? Alright, and then we have also this little report. As we all know, recently, the DART project to deorbit the moonlet Dimorphos around Didymos has shrunk by 32 minutes after exceeding mission requirements. So in late September, a 570 kilogram spacecraft travelling at 22,530 kilometres an hour smacked directly into a small asteroid named Dimorphos, throwing up a massive cloud of dusty debris. The hit was intentional. The accumulation of NASA's Double Asteroid Redirection Test, DART, designed to determine whether a kinetic impact hitting an asteroid with the spacecraft could change its trajectory. The target, Dimorphos, is 525 feet wide, or 160 meters. Oh, there we are. It's a 160-meter asteroid. Sorry. Moonlet orbiting a large asteroid, 65803 Didymos, which is 780 meters across. DART's goal was to adjust the orbit of Dimorphos around Didymos, aiming it to alter its nearly 12-hour period by at least 73 seconds. And it succeeded. After following the pair for 2 weeks, NASA announced yesterday that Dimorphos' 11-hour and 55-minute orbit has shrunk to 11 hours and 23 minutes, a difference of 32 minutes. That's roughly 26 times the mission 73-second baseline for success. That's roughly 26 times the mission's 73-second baseline for success. I see, okay. So, it's a watershed moment in the field of planetary defense, which aims to understand and ideally mitigate the risks posed to Earth from asteroids and comets that may cross our planet's Earth path. As new data come in each day, astronomers will be able to better assess whether and how a mission like DART could be used in the future to help protect Earth from a collision with an asteroid, if ever discover one heading our way, said NASA. The mission can now be crowned a success, but despite the fact that DART spacecraft has been smashed to smithereens, researchers' work is far from complete. In particular, scientists are eager to study the huge cloud of dust and debris thrown out by the impact, which stretches at least 10,000 kilometres long and has persisted for weeks. Images from several observatories include CFHT and SAW telescopes show Dimorphos sporting a stunning comet-like tail, which I showed last week. At last week's Division of Planetary Sciences conference in London, Ontario. There's a London in Ontario? Guess so. Several researchers commented on the surprising and intriguing nature of this lingering debris, whose long-term presence was somewhat unexpected. There it goes. Alrighty then. Now, have I got a picture up? No, it's me. It's okay. All right. Excuse me. NASA's now targeting the 14th of November for Artemis 1 moon launch. The highly anticipated Artemis 1 mission has a 69-minute launch window opening at 12:07 a.m. ET on the 14th of November. So we have to wait for that, for hopefully a successful launch. And I've learnt a new term in the last week in regards to astronomy and things that go on with measurements. There's a term called tired light. It's a bit like what you're seeing coming off my face right now. It's very tired. This cup of coffee has lasted me 60 minutes so far. Not quite cold. Tired light is a class of hypothetical redshift mechanisms that was proposed as an alternative explanation for the redshift distance relationship. These models have been proposed as alternatives to the models that require metric expansion of space, of which the Big Bang and the steady state cosmologies are the most famous examples. The concept was first proposed in 1929 by Fritz Zwicky, who suggested that if photons lost energy over time through collisions with other particles in a regular way, the more distant objects would appear redder than the more nearby ones. Zicke himself acknowledged that any sort of scattering of light would blur the images of distant objects more than what is seen. Additionally, the surface brightness of galaxies evolving with time and time dilation of cosmological sources and a thermal spectrum of cosmic microwave background have been observed. These effects should not be presented if the cosmological redshift was due to any tired light scattering mechanism. Tired light was an idea that came about due to the observation made by Edwin Hubble that distant galaxies have redshifts proportional to their distance. That's all I'm going to say on that matter. But there it is. There's a new term. It's actually not a new term. It's been around for a while. But in all the years that I have been involved with astronomy, and particularly radio astronomy, I've never heard of the term tired light. So there it is. Look it up on Wikipedia. Space.com, that is spaceweather.com. Alright, we have a sun to bring up. My 160 meter transmitter is having a bit of a hernia. It just doesn't like 60 minutes of AM. And it's not the transmitter, it's the linear. Alright. The solar wind is currently at a speed of 378.7 kilometers a second at a density of 8.38 protons per cubic centimeter. The disk of the sun, the current disk of the sun, which you can see on YouTube channel right now, has three. Is it three? It looks like three, maybe four sunspots on the disk. Can't quite make out the numbers there because they're all on top of each other. But there's at least three sunspots on the disk of the sun as we speak. There is the radio sun is currently at 141 solar flux units, measured at a wavelength of 10.7 centimeters. So 141 solar flux units. Geomagnetic activity, a CME, may have just passed Earth, not hitting but nevertheless upsetting our planet's magnetic field. The solar wind data from NOAA's Discover spacecraft show an unexpected upsurge in dense magnetized plasma around midnight on October 13 and 14. This ongoing event has triggered some bright auroras around the Arctic Circle. Okay. Now, there's a couple of images I want to show there too. The current aurora. Oh, I didn't pass that image through. There's always an image I forget to add into my little list of images here. I know it's there. There it is. Just bringing this into vMix so I can show you guys. There it is. Okay. So that's the current image, probably delayed by about half an hour or so, but that's the current auroral ring over the Antarctic South Pole, which is a little intense, but probably fairly normal for things at the moment. And the other thing this is what I wanted to show you last week. There's the cycle for sunspots and for the solar flux, the radio solar flux measurements. And as you can see, we're still about a quarter of the way up the cycle, of the 11-year cycle. But you can see how the trend, which is the red line, and what's in reality being recorded. So the top is the sunspot recorded activity, and below is the radio flux measurements being recorded. And you can see how close the solar sunspot activity is with the radio. It mirrors almost perfectly. But as you can see, the 25th cycle that we're about to come into is still to peak. And if you go by the timeline at the bottom here, we're still at least 2, maybe 3 years away from reaching the peak of our solar cycle, going by those charts there. But it looks like the next peak is going to be quite high. So you amateurs out there that enjoy the DX on 20 meters or HF elsewhere, by all means, get those HF radios fired up, because it's going to be very exciting stuff over the next couple of years or so. QRP, not a problem for those that love QRP. All right, I can see that it's 6 minutes past 11. It's just got there, so and I'm still streaming too. I haven't dropped out, which is a good thing. I think that's about it for tonight. Yeah, I haven't got anything else. There's no new reports from Tamitha Scove. There is actually, she has, like I said last week, she occasionally puts out very long reports, solar reports, sometimes up to an hour, and sometimes they go for an hour and a half or so. I haven't quite sat in on the solar reports that she does that goes for an hour plus. Suffice to say that I'm sure it's very, very detailed. And she's also answering questions on the fly because she has an ongoing little chat window that runs next to her YouTube channel. And if anybody asks questions, she generally tries to answer them as she goes. So 10 days ago was her last long solar report. I only look out for the condensed solar reports for about 8 minutes or so, which she hasn't done, unfortunately. Otherwise, I would have squeezed it in tonight's broadcast. But having said that, if you want to explore what Tamitha does, all her videos is available on the YouTube channel. Just type in Space Weather Woman. That's basically it. Space Weather Woman, Tamitha Scove, and you'll find a lot of little videos there that she's done. Just a bit of a plug for Tamitha there. And again, don't forget to catch up with the midweek ASV's monthly meeting, Exploring the Invisible Universe in Radio Colour by Kat Ross. You can find that by also typing in the ASV, the Astronomical Society of Victoria, in the YouTube search engine, and you'll find last Wednesday's presentation by Kat Ross, a postdoctoral researcher who's doing lots of good things. Okay, I think that's about it. Finally. Thanks, Don. Don sent me a report. He says, good broadcast tonight. 40 over 9 on 80 and 30 dB over 9 on 160. Great sounds. Ian, VK3VIN, says he's listening on 80 metres tonight, and a good 10 to 30 over 9 signals on 80. And we have, all right, we have VK2 EMF, who's joined in on the chat window. G'day, I've forgotten your name. I can't see it there, Rich. No. What's your name, Mr. EMF? G'day, Joe, VK3BKI. He was there. Richard, VK3VRS. Kim, VK5FUSE. G'day, Kim. And that's about it I can see on the chat window. And Kim is typing something as I speak. So, all right, on that note, we shall conclude tonight's broadcast service on behalf of the Astronomical Society of Victoria. We hope that you enjoyed the last 70 minutes of nonsense, and we'll be back next Friday to do it all again. But I must try and get to bed earlier. I've only had about 5 hours sleep today, not even that, about 4, so I'm a bit seedy, as they say. No worries, Kim. So thanks, ladies and gentlemen, and boys and girls, if there are any, for listening to tonight's missions. And again, we'll be back next week. Thanks for watching the YouTube channel. Hopefully next Friday we'll have the RTV repeater back online, so we'll be running HD images through the digital repeater VK3 RTV. In the meantime, have a safe weekend. Look after yourselves. I haven't quite finished yet. I'm going to do a quick call back on 80 metres. I'm almost ahead of myself here. This is VK3 Echo Kilo Hotel with VK3 CSJ on the microphone on behalf of the Astronomical Society of Victoria, concluding our medium wave service on 1865. Thanks for listening to all our AM listeners out there. Thanks for listening to our AM signal. And we shall now kill this transmitter and leave the frequency clear to VK3SL, who will come up in a short while with his test transmissions. This is VK3 EKH concluding on 1865. Standby stations on 80 meters. All right, so 160 is off. And do I have my pad? Yes, here's my pad, and there's my pen. Stand by. That's my logbook. And for those watching on YouTube. So, this is VK3 EKH. Oops, hang on a sec. I've got to switch my speaker. Hang on a sec. All right, I've got the one speaker connected to two radios at the moment, so I've got to remember to select the right speaker for the 80 meter service. This is VK3 EKH, listening on 3541 kilohertz for any stations wishing to call back. Alrighty, VK3VIN and VK5 Whiskey Alpha. Is there anybody else out there? See, that's it. If I go 10 minutes over the time, people just drop off. Well, that's my fault for going over time, but it doesn't worry me. It's all very fine stuff. Have a say, Ian. VK3VIN, VK3 EKH. Yeah, no worries, Ian. VK3VIN, Kangaroo Flat, VK3 EKH returning. Thanks, Ian. Yeah, not a superiorly strong signal tonight, but you're hovering around 15 to 20, so you can't complain about that. Didn't really notice any QSB, so it's a fairly steady signal that I'm seeing from you here. So, but I'm not really sure how the propagation is tonight for 80 meters. Yeah, I guess given the stations that have tuned in up there on the Discord channel, I suspect that we're getting out far and wide. So that's the main thing. And I guess maybe I should apologise for the overload in the news items. I could probably cut down the whole session by 15 minutes or maybe even half an hour. I mean, the original broadcast that was done here by Russell, VK3DRW, before I took over the microphone, his broadcasts usually went for about, I don't know, half an hour, maybe 40 minutes. But he would generally read out just the one thing. Normally it would be something of some astronomical historical significance, and he would just read out this story. And so it would be generally just the one item, and so his broadcasts when he was doing it would be generally about half an hour or so. Maybe I need to go back to that method. Arrangement. I don't know. But when I took over the microphone some 12 years ago, I figured let's just make it a news thing. Let's just bring out all the latest in astronomy and news, and because generally they're all short articles. I try to get the short articles, and do it that way. So that's what I've been doing, and that includes TV and whatnot. So there it is. Thanks, Ian. Now I think it's Dallas. VK5 Whiskey Alpha, VK3 EKH. Yeah, no worries, Dallas. VK5 Whiskey Alpha, VK3 Charlie Sierra, VK3 EKH returning. And yeah, you're 20 over 9, coming through at about 20 over 9. So a mightily good signal coming into Narre Warren tonight. So not a problem, Dallas. And thank you for the comments too. Yeah, look, I don't think I'll do any mass changes right now because I do enjoy the video side of it, you know, running the YouTube stream and running the same video information by the Melbourne television repeater. Being able to run the images through from the various articles, because all the articles that I read, they all carry either genuine images or artists' impressions or something along that line, and it's always nice to be able to complement what I'm saying over the HF radio to the YouTube channel, even though there is a delay. There's not much I can do about that. But I know there is a significant delay in the YouTube stream compared to what I'm saying on air. So that's one of the reasons why I tend to leave the image up for a while, so it sort of blends in somehow. But that's another story. All right, thanks, Dallas. Good to hear you. It's been a while, but we're still here most Fridays. It's rapidly coming up to the end of this year. It's scary stuff. All right, I'm going to take one more listen on the band and on the frequency and see if there's anybody else. This is VK3 EKH, listening on 3541. I don't know, if there was a station, it was very, very weak, but it was a zero copy here, really. All right, look, thanks everybody for listening tonight, and everybody that's up there on the chat window, Kim, Cassiopeia, Joe, and John, Mr. BLX, all you guys, Richard, thanks for coming up on chat, and again, also thanks for the email reports from you guys, so all appreciated. At 20 past the hour, we'll say a very pleasant good evening, and hopefully the flooding situation hasn't been too much of a problem for the folks here in Victoria that are on HF, on shortwave, whatever. So cheers for now. Take care. Have a comfortable weekend. I'm actually seeing Professor Brian Cox tomorrow afternoon, so I shall report next Friday on his presentation. Unfortunately, the tickets are a bit expensive depending on where you sit. But I figured if Carl Sagan was still alive, and he decided to come into Melbourne to do a talk to the public, a public lecture, I would probably go. But since Carl Sagan is no longer with us, a missed opportunity, although I don't think Carl Sagan did the lecture circuit in his time. But Professor Brian Cox is about the modern day equivalent to Carl Sagan, and he does some bloody good documentaries. So he's in He's in Melbourne this weekend, so I'm definitely looking forward to catching him tomorrow afternoon in Melbourne, and I shall do a report next Friday on how it went. This is VK3A. No, it's not VK3ASV. See how tired I am. This is VK3EKH, the official station of the Astronomical Society of Victoria, concluding transmissions for tonight. See you guys next Friday. We're over and out. Cheers, everyone. Bye. Alright, cheers everybody watching YouTube. Thanks for watching, and subscribe and tick the like button if you wish. It's totally up to you. So stand by for some wonderful set of colour bars. Take care and look after yourselves. And I did this without my ID up. My goodness me, I didn't. Where were you, Richard? You must have fallen asleep. Never mind. There's the little ID that I should have had up on the screen all this time. Anyway, doesn't matter. Cheers, everyone. And kill the audio.